Welcome to EQUUS Farm Calls, where we take horse owners along with us to discuss important topics on equine health and care with industry experts. Today, we're talking to Dr. Samantha Brooks about genetics and horse health. EQUUS Farm Calls is brought to you in 2022 by Farnam, the makers of Max Flex XR Extended Release Joint Supplement. Your horse's joints work around the clock. Shouldn't your joint supplement do the same? Max Flex XR Extended Release Joint Formula keeps glucosamine in the system a full 24 hours. Extended release technology slowly releases glucosamine, providing a constant supply to the joints. That's 24 times longer than other joint supplements. A win for you and your horse. Provide support for hardworking joints with Max Flex XR Extended Release Joint Formula. One daily dose provides 24-hour joint care to help keep your horse in motion. I'm Kim Brown, group publisher of the Equine Health Network. Dr. Brooks, who's a PhD in veterinary science, is an associate professor of equine physiology in the Department of Animal Sciences at the University of Florida. Her research program explores a variety of topics relevant to horse health, ranging from gene expression studies to mapping of genetic disorders in the horse. Previously, her research group discovered genetic mutations and markers for coat colors, height, sarcoid tumors, and 2 neurological conditions. Ongoing work of the group targets variation in gait, susceptibility to infectious disease, metabolic syndrome and skeletal defects using genome-wide association, and genome resequencing. So thank you, Dr. Brooks, for joining us today on EQUUS Farm Calls podcast to talk about genetics and horse health.
Great. Thanks, Kim. I'm glad to be here.
Well, the list of topics you and your group are researching in horses using genetics is fascinating. So let's start with something simple like coat colors. But I guess my question is it really that simple?
Well, coat color is one of those topics we all kind of love to hate. Horse owners, we know how important color is. Our research program, aside from always trying to maintain health of the horse, we do try to focus on the traits that are of greatest economic value, because at the end of the day, we all have to pay our bills, right? And so right now, our studies are focusing a lot on what I call sound and sane. But at the end of the day, after sound and sane, coat color really pulls at our heartstrings more than a lot of other kind of traits in the horse. And often they can tell some very illustrative studies about how genetics works to help us all learn a little bit better how we can use genetic tools to help to improve the marketability and the health of our horses. So, coat colors, I like to say sometimes they're easy, but sometimes they just aren't. They do some really amazing things. But one of the neat things about studying coat color is that some of the genes that impact color also impact important health traits. So there's 2 really interesting examples of that. One is one that's been around for a long time. That's lethal white overo syndrome, right? Still have to keep talking about this one because folks, we tend to forget that we actually can test for that and can pretty easily avoid that lethal syndrome. So when it comes to overo, 1 copy gives you that beautiful spotting pattern that we really enjoy. But if a horse has 2 copies of that allele, of that particular version of the gene, they would have inherited one from mom and one from dad. They're born entirely white and they have a dysfunctional gastrointestinal system. So their intestines just don't work correctly. And these little foals, if they make it to term, they're so sick, they inevitably end up needing euthanasia from some very catastrophic colic. That's a pretty big swing, right? Because 1 copy gives you a more marketable horse. 2 copies gives you a dead horse. So that's something that a producer really needs to get a handle on. But it just kind of illustrates that, it's the same gene, it's the same change, but genes are a little bit like Swiss Army knives. Right? So in the skin, it's doing one function, and in the gut, it's doing another, but it's the same tool. So when that tool is dysfunctional from a genetic change, it could have impacts in seemingly unrelated different body systems. One of the really interesting things that we've discovered is that we used to love to study coat color, still do, I guess, one of my favorite topics, because the inheritance patterns tended to be pretty easy to predict, at least as far as genetics goes. But what we've discovered is that when we initially described these variants, things like frame overo, we actually made way too many assumptions. and we like to say that when a horse has one copy of the overo gene, you get that spotting pattern because it's easy. But some of our recent work that we've done in the American paint horse has documented that as many as 10% of horses carrying that single allele actually do not show any spotting pattern whatsoever. 1 in 10 of those horses. I actually happen to have one in my backyard right here. We thought she was just a grade horse, and we went and tested her, and sure enough, she carried a frame overo. And she came to us with no papers, with no history, right? And my daughter, if I win the lottery, my daughter would love to breed her little 4-H mare because she is so cute. So cute. But had we gone into that without genetic testing, and if we were aiming for getting some nice chromy, splashy, overo patterned horses, we might have ended up choosing a cross that could have gotten us a lethal white overo foal, and that would have been heartbreaking.
And I know in the news just in the last couple of weeks in Australia, there was a thoroughbred born that had almost a paint coat color. And of course, everybody was like, somebody got into that mare and so forth. But they were able to prove genetically that was just a one-off mutation of this horse. I mean, to me, that's fascinating.
Right. So everybody accumulates new genetic variants. DNA isn't copied with perfect fidelity each time we make a new gamete, a sperm or an egg cell. And then sometimes spontaneous mutations happen during development. It's just that, they're happening throughout the genome, but we only see them when they're kind of, blatantly obvious written across the side of the horse. So we really, all of those variants are happening all the time. But when they drastically change the appearance of the horse, all of a sudden that's when we take notice. But there are a couple genes, KIT in particular, that seems to be a very popular target for these novel spontaneous mutations. And we're up around 40 now with all the publications that are coming out and on the way. 40 different alleles, many of those being spontaneous white or white marked horses that genetic research has gone through and discovered that, in fact, they had a mutation that occurred in recent history. Sometimes even we find the foal, that story of somebody jumped the fence. That happens quite often, right? So we've published a couple of papers on foals that were the first to have a new spotting pattern.
Yeah, I remember when the first white thoroughbred was born, and that was before we had a lot of the genetic testing we have today. And it took a long time for that horse, that thoroughbred, to get registered to be able to race and get a pedigree.
Oh, for sure. Those spontaneous mutations, they've been happening regularly for the last 200 years. It's just, it used to be when it happened, that foal got sold down the road or buried in the back 40, and people would kind of hide that, assuming that there had been something happen that shouldn't. Then parentage testing helped out a lot, right? Because once we had parentage verification using our DNA testing, then we could prove that, in fact, the parentage was correct. The foal just looked a little unusual. So once we had that kind of tool, then some of our thoroughbred breeders began to say, hey, wait a minute, this actually is something special. It's not something we should be ashamed of.
Well, and another thing, of course, that's important, not only to the use of the horse, but sometimes to the financial worth of the horse's height. And honestly, I didn't know that we could, you figure, okay, you get a big mare and a big stud, you're going to get a big foal. And, but if you get a big mare and a smaller stud, which we've all seen in, breedings. So how does height work?
Well, height's pretty cool. Height is another great classic genetic trait to study because, it's something that is pretty measurable. It does have environmental influence, right? So we all know if you get insufficient nutrition, you can decrease height when you're growing. And also, if you get excessive nutrition, you can get all sorts of orthopedic disorders, things like OCD or osteochondrosis dissecans. You can progress. That disease is in part due to some environmental components interacting with growth and susceptibility. In the horse, we have documented, well, I'll say about 5 different genetic changes that impact height. And some of those are more specific to some breeds. Like many of our pony breeds have some variants that are strongly selected for that helps them to stay small. Just as we as breeders and agriculturalists have selected them for small height, we've kind of fixed those. And then there are others that are common to many horse breeds. And one of my favorite genetic sites to study is a variant that's near a gene called L-Coral in the acronym. It's not particularly important. That's just what we happen to name it. And we first came upon that allele when we did a pilot study where we actually got very lucky. And in a fairly small sample size, when we compared all the way from miniature horses up to some of the largest draft horses, we identified this L-Coral site as having a strong influence on height. Then later on, some of my collaborators up at Cornell were working on a condition called RLN, a recurrent laryngeal neuropathy.
Uh-huh.
Our horse breeders will know that as roaring, especially if you work with race horses or sport horses. These are the horses that have some noisy airways and have a hard time working at maximal exertion, especially for our flat course racing horses. They were working on roaring, and as they mapped something, they came to me and they said, we have messed up. They said, this can't be right because we have exactly the same spot that you guys just mapped for height. And I was like, oh, no. And sure enough, when we picked it apart statistically, the very same genetic variation that was giving within the thoroughbred 3 extra inches of height at the withers was also increasing the risk for roaring.
Ah.
So from the wild type or reference, the generic version of the gene, if you accumulated 2 of these variants at L-Coral, you were homozygous for it, it would increase your height by 3 inches at the withers. It would increase your risk of developing roaring by almost 12-fold.
Wow.
That was a conundrum. And we still aren't 100% certain exactly how that relationship is coming about. It could be that this L-Coral gene is important for signaling growth and maybe also somehow important for signaling neurons, especially the neurons that will help to hold that airway open while the horse is running. It could also be that growth plays a part in both conditions. So obviously when you need to grow tall, you have to grow at the right time. But maybe somehow that growth is having some interaction with development of the neuron, particularly early on, and making it susceptible to damage. We would love to follow up on that study. Unfortunately, we haven't been able to get sufficient research funding. Just to kind of add to the mystery, some of our colleagues in Germany are also studying OCD, right? So remember I mentioned that if you have a young horse who is on an excessively high plane of nutrition, which happens actually not infrequently, especially with our thoroughbreds and our quarter horses, when they go to sales as youngsters, we like to see them looking bold and strong and substantial and well-muscled, right? But at that stage of growth, that puts them, they have to eat quite a lot of calories to keep on that much weight and to look that filled out. And as it turned out, those extra calories are giving them a little higher risk for having problems with their joints. And our friends in Germany, when they looked at some warm blood populations of horses, they found that among a couple different regions in the genome, that same L-Coral gene was conferring risk for developing OCD, particularly in the hock. So this same locus, it's under strong selection in the thoroughbred because early studies have shown that having a longer limb, especially a longer shoulder, correlates with increased earnings on the track. So as we select for increased earnings, our thoroughbreds are getting taller. They've gotten about 4 inches taller in the last 100 years based on historical records. So we're selecting strongly for height. But at the same time, by selecting for height, we are also increasing the frequency of OCD and increasing the frequency of recurrent laryngeal neuropathy.
Wow.
So then the question is, now what do we do, right? Well, the good news is that as we learn more about what this L-coral gene does, it might give us ways to specifically intervene. So at the very least, you can buy a genetic test for this L-coral height locus now. If you have a tall mare who has one L-coral tall height and RLN risk, you can potentially look for a stallion who's tall, if you want a tall horse, but does not have this particular risk allele. And that may help because we haven't seen recurrent laryngeal neuropathy tied to some of the other height genes yet. Doesn't mean that that effect isn't there, and it may just be small enough we haven't had enough time and money to ferret it out, but it doesn't seem to be there. So you can select a stallion who will help to mitigate your risk. Or if you're out buying yearlings, you can look for a yearling who looks like he's got good conformation, good bone structure, is nice and solid, but does not have this allele, so that you can help to reduce your chances at 3 years down the road, once you put a bunch of money into training him, that he's going to develop a bad airway and may end up having to need a tie-back surgery or may never be able to perform to his full potential. So you've got preventative strategies that you can use, that environmental interaction. If you have the knowledge that you can gain from that genetic testing, as owners and breeders and horse health managers, you can start to use some of the interventions that we have. And then hopefully down the road, much like we've done for HYPP and PSSM, maybe we can figure out ways to very specifically work with that genetic change and begin to mitigate the negative sides of it so that we can sort of optimize the benefits. Like, we really do like that increased height as horse breeders.
That's cool. So what else? I mean, I know we could talk about this all day. You and I have talked before, and unfortunately, we won't do this to our audience, but we talk for about 2 hours. But let's talk about something else. I know sarcoids. That's something that a lot of horse owners have to deal with in their horses. I didn't know we'd done any genetic research on sarcoid tumors.
Yeah, for sure. So one of my former PhD students, a PhD graduate of mine, Dr. Ann Steiger, one of the studies that she worked on during her PhD in collaboration with Doug Anzac at Cornell was to look specifically at the severity of sarcoids. So sarcoids, we know that there's a viral component to that, right? And we used to think it was part of the bovine papillomavirus family. Now we think there may be an equine specific variant, but this virus is likely carried around by maybe on the feet of flies or by, rubbing on fences. We really don't fully understand the pathogenesis of it, but there's an infectious part. And then there's the part about how the body reacts to that infection. So Anne in particular was looking at differences in the severity of the sarcoid. So why will some horses get a sarcoid and it'll always be, maybe this flat little thing that's not a lot of trouble. And then other horses will get these enormous ulcerated, pendulous, big sarcoid tumors that are very, very difficult to treat and become a real quality of life challenge. We have known for a while that there was a big difference in susceptibility. And even some species of zebras, when they get sarcoids, they'll get these enormous basketball-sized tumors that are just, a very, very different kind of disease from what most of us know as our garden variety sarcoid. So in her case, she used this genome-wide association strategy to help to compare genetic markers between horses who had mild sarcoids and those who had more severe sarcoids. And sure enough, we came up with an interesting association site that, someday my hope is that with the help of our virologist friends and our clinicians, is we might be able to better understand the functions of the genes in that region so we can figure out what genetic pathway is actually conferring this aggressive sort of response and creation of these very, very large tumors. We think it may have something to do with DNA repair. There's a couple different hypotheses there, and we'll be super excited to get back to that. But if anyone has ever had a horse with one of these sarcoids that is resistant to treatment, you know that it is so frustrating because they're just tough. And it's a type of disease where I really feel like genetics is a great tool to go to use because it can help to uncover entirely new ideas about how the disease comes about that can, kind of flip the switch a bit and make us consider the problem from an entirely new angle. One of my other favorite stories right now about terrible diseases that we can do nothing about is anhydrosis, or non-sweaters. And this time of year, particularly, here in Florida, we had our first 100-degree day yesterday, and it's about that time of year where I'm going to start getting lots of calls from desperate horse owners whose horses are very critically at risk from hyperthermia, from overheating, because they don't sweat correctly. So a couple years ago, I have another PhD graduate, Dr. Laura Patterson-Rosa. She because we knew nothing about this disease and we had no effective treatments. There are no proper scientifically proven effective treatments for anhydrosis. There are hundreds of supplements out there, and everybody says, oh, you just have to find the right combination of supplements. Well, we have no scientific evidence that that's true. So without any good treatment tools, we're really left with, we just have to start from scratch. And genetics is a great way to do that, because it will point us towards some of the most basic biological pathways that are triggering some of these diseases. So she looked at a group of quarter horses and thoroughbreds, and again, compared the genetic markers in horses who had mild to no evidence of anhydrosis, although they were mature horses, and then those that were very, very severely affected. And ultimately, she identified one region of the genome that is a strong influence. It's not the whole story. It doesn't completely explain anhydrosis the way an overo allele can explain lethal white overo syndrome, but it is an important trigger factor. And in that gene region, we have our eye on a couple different sites, but our favorite potential suspect is important for trafficking potassium alleles, potassium ions across the cell membrane. And so everybody knows, especially if you work outside in hot weather, that getting electrolytes is important for making sure that you can stay properly hydrated and that you can sweat appropriately. And ironically, horses and humans are two of only about 3 mammalian species that utilize sweat as our primary thermoregulatory mechanism. So it's super, super important for us and for the horses. So we've put in a couple grants to try to better understand this particular potassium channel, because if it's the culprit, there are literally hundreds of different drugs that were developed to treat diseases in people like cystic fibrosis that might impact this channel and might be far enough along in the development process that we could potentially get it economically in the range where we could get the doses that would be suitable for a horse.
Wow.
And that would be fantastic, because if anyone has ever had an anhydrosis horse, it's really, really tough. And if our hypothesis is true, and a lot of the histology studies that have looked in the sweat glands of horses seem to support this, it looks like that as this horse goes through life, those sweat glands are accumulating damage, and that damage might be irreversible. It really looks that way. Their sweat glands have scarring on them. That means that what we really need to do is start to be able to maybe test these horses for that genetic risk factor and consider protecting them. So maybe that's the horse that needs to be in a climate where you have shorter summers.
Right.
Doesn't mean that they won't have anhydrosis, right? Because even we were in upstate New York and we had samples sent to us from Canada and from Ireland and all around the world. In any climate, if the day gets hot enough that horse struggles to thermoregulate, they can suffer from anhydrosis. But at least there are fewer dangerous days in cooler climates, right? So if you know that you're going to want to take your dressage horse to Wellington for a long season, wouldn't it be nice when you go shopping for him if you double check and make sure that he's likely to be able to sweat strongly? Because the last thing you want to do is import an expensive horse and spend tons of money getting him trained and into competition, only to find that a month into the season he stopped sweating and is now unable to perform, right?
Correct, yeah. Or even a lower level for somebody who, gets a horse that has moved down in its disciplines, and maybe it came out of a foreign country or Canada, and you live in Texas or Florida, and suddenly it's in an environment it's never seen before.
Right. Yeah. It can definitely fly under the radar for sure. And anhydrosis, it's a very democratic disease. One of our most heartbreaking stories from a study participant was was from a 12-year-old boy who had lost his 4-H horse. He had actually died while out working cattle in the heat from anhydrosis. He just critically overheated, and it came on fairly quickly. You know, the horse had always been a fairly low-key, nice, quiet, solid family horse. And so they thought his relaxed demeanor was part of his personality, and probably it was. But part of it could have been that he knew that if he overexerted himself, he got too hot. And sure enough, on a Florida day, he got too hot and ended up passing away from overheating, which is not a fun way to go. Not a fun way to go.
Well, and that's kind of like when I still lived in Kentucky. I live in Wyoming now. I had bought a horse out of Wyoming for Kentucky. Beautiful, mature mare, and turned her out on the, beautiful Kentucky grass. And come to find out, she had PSSM type 1.
Oh, no.
My veterinarian in Kentucky said they had never seen a horse tie up that bad. Of course, in Wyoming, there's no grass to graze. It's a whole different climate. And suddenly she's, and without the knowledge. And I ended up buying another horse from Wyoming. And I said, look, I want to test the horse for this. Wasn't the same genetics or anything. And it was, I said, it's not a deal breaker. It's just a management tool. That way I know how to manage it. And he ended up not having it, but this mare came from some foundation quarter horse stock that was known for passing these genetics along. I didn't know enough about it, but, with management, she was just fine. But, without the management, it was a little sad to see her when she tied up that time so badly. So it was sad. But so let's talk a little about neurologic and metabolic. I mean, we have come so far just in my lifetime on being able to identify and manage some of these horses.
Oh, yeah, absolutely. For horse breeders and owners, that's the power of genetics, right? So a lot of horse owners will say, I don't want to test because, even if they're positive, I'm not going to stop breeding my stallion, or I'm not going to stop breeding my mare. Or, if my stallion is positive, it'll mean the end of my business. So no, I don't want to test because it potentially could crush our marketability of our horse. And unfortunately, that's the ostrich with their head in the sand kind of strategy for things, right? Horses, we manage them as individuals. We don't manage them as herds most of the time. And we keep them for up to 30 years, right? So culling and strategically breeding mostly, sure, it has a role. But most of the time, we're going to end up trying to manage our way around these things. And horses are not inexpensive, right? So the more knowledge we have so that we can better tune our management of that animal, the better off we're going to be. And with some diseases like PSSM, it can mean life or death, that knowledge of what that horse might carry. We actually had a student once here at UF who had a very promising young quarter horse that they sent in to the trainer because this was something it was a homebred little mare, and they were just so optimistic about her potential that they made a huge sacrifice to spend the money to send her to a professional trainer. And that little mare, when they got to the trainer put her on a performance feed, a very good quality performance feed, but it happened to be pretty high in those sugars. And she ultimately had a PSSM attack that was so severe, caused kidney damage, and she actually had to be euthanized. Right. So these things are not trivial, right? They potentially can be life or death. Even something like PSSM that thousands upon thousands of quarter horses are living with every single day. And up to half of our heavy draft horses in the Percheron breed, particularly, have PSSM and live with it every day. But if we go into it blindly, and sometimes we do things that are very industry standard, like using a good quality performance feed in a young athletic animal, right? This was the smart decision, except for that, didn't have all the information, right? So having all the information is at least as much as we can get. It's really an investment. A lot of our people that we speak to, especially the small time breeders that have just a mare or two, they really complain about the cost of genetic testing. But at the end of the day, it is so much less expensive than having a horse in critical care at a referral hospital or potentially losing a foal and losing a breeding season. It's an investment, but it's definitely pays off in the long term. And our costs are coming down every day. You know, all the fantastic technologies that are coming out of human medicine trickle down to animal medicine as well. And the cost of genetic diagnostics is coming down every single day, especially if you're a real savvy shopper and look around and look for companies that are starting to create these big bundled packages where you can get lots of tests together for, it's a buy in bulk kind of situation with genetic markers and with strawberries, right? So there's some situations now that because of new genetic testing technologies, you can get a lot more bang for your buck than you used to be able to.
For just the normal owner who's buying a horse, the genetic testing didn't cost me that much on that gelding. But it saved me a lot of time, money, and heartbreak because I knew more how to manage him. And he was not PSSM positive, but still that allowed me to know that so that I could manage him differently. If I'd known that about the mare when I bought her, and again, it wasn't that expensive to get the test done, but all the treatment and the vet visits and everything else I had to do, building dry lots and all that was expensive. But once done, she had a long life where she was just amazing. But I also had a lot of people want me to breed her. And I was like, there are too many really good horses without genetic defects. Let's not take the possibility that down the road, if she has a filly and she passes that along and someone else breeds to a stallion that's carrying that, let's just not do that. It's a responsibility that horse owners have.
It is a responsibility, and it's a big responsibility because, again, these horses they're not inexpensive and they're not easily replaced, and they can be with us for up to 30 years. So one moment of weakness and one temptation where you think, I'll make that cross and we'll just hope for the best, It can lead because, you never know where your horses end up. We all hope that we're going to be able to keep them with us forever. Or if you're selling them, you always hope that every horse you sell goes to a good owner who will have them forever. And they won't end up in an auction house or, on a truck going to Canada, right? But sometimes crazy things happen. And so let's say this horse ends up in a rescue, like our little 4-H mare we have in the backyard here. She got separated from her papers, got separated from her health history, from her pedigree, everything. And we easily could have made a mistake had we chosen to breed her. And it's hard to make a decision not to potentially breed your favorite horse. We have this debate all the time, even here at UF in our quarter horse herd. We are always struggling with the super marketability of some of our stallions today. But also, a lot of those horses will carry an allele or two. And it's not to say that we should discard every horse because they carry an allele that has negative defects. No. I mean, you don't want to throw the baby out with the bathwater, right? But you have to think very carefully about the long term. And here at UF, we sell our full crop every year as 2-year-olds in a big auction, and then we don't know what happens. And with geldings, you can geld them, and then they're not going to breed in the future. But with mares, spaying is not something a lot of horse owners want done to their mare before it's sold, right? So with a mare, it's a real liability. And if we let that horse go out the door knowing she carries something like PSSM that can be potentially danger to her and potentially a danger to future generations, it's tough. So, we try to maximize the good and minimize the liability, just like with any other economic decision. And it really does. It comes down to the dollars and cents. When people worry about the ethics, they worry about, I need to preserve the bloodlines. Well, that's true too. They worry about the emotional cost, the emotional tie they have to a horse. But, like your example, that one PSSM test probably costs less than a single farm visit fee from your veterinarian. Even just one farm visit, and you've already recouped your money. Not to mention the cost of your dry lots and multiple visits and everything else.
Because I've never seen a horse tie up before, and it was oh my gosh, I think because I've read about this, I know what it is, but it was scary. So, and not every genetic defect is bad. There are some that we know that we can look at and maybe manipulate for the good, like you're talking about the height gene. But again, as I told our audience to start with, you and I get started and we could talk about these things for days because we have so much fun with it. But what I'm going to do is I'm going to thank you, Dr. Brooks, for joining us today on EQUUS Farm Calls. And I want to thank our audience for joining us. And if you have questions that might be genetic related, maybe we could talk Dr. Brooks into coming back and talking about some other conditions that our audience is interested in. And if you have those, shoot me an email to kbrown, that's the letter K Brown, at equinenetwork.com. And we'll see what we can do to talk Dr. Brooks to join us again. Thank you, Dr. Brooks. We really appreciate it.
Thank you. It's been lots of fun. And yeah, I'll look forward to seeing those questions from all those horse owners out there.